you to the organizers for inviting me to give this talk today. I will have to make two confessions. One, I am a biologist by training, and I will be discussing a lot of development issues. Bear with me for the difficulties when you ask questions. And also, my presentation, it's a little longer than I had planned, so I'm going to do my best to skip on less important things so that I can reach the time. I'm Moni Munoz Torres, and I have the privilege to be part of a very good development team at Lawrence Berkeley National Laboratory. We are the developers of software for the Gene Ontology Consortium, as well as Web Apollo, which is what I'm going to be talking about today. By no stretch of the imagination am I saying that I am solely responsible for this. Nathan Dunn is our newly hired technical lead and the mastermind behind all of these architectural changes that I will be discussing today. Wish he was here today as well. And we also have collaborators at the University of Missouri and the LSEC lab. We have Deepak Uni and Colin Dish, and really good collaborators that help us as well with some of the development, Stephen Ficklin and Eric Zhao at UC Berkeley and at Washington State University. We're hoping that our tools actually allow scientists to put their mind to work, use our tools, and be successful in conducting genome annotation efforts. And you can find all about this and many other topics about our lab in genomearchitect.org. My outline then is I'll walk very briefly through why we bother to work with Web Apollo in the context of manual annotation and curation. And then I'll discuss the improvements that we have conducted in terms of architecture, how we've tried to make it a more scalable tool, and the features that we've implemented as of late. And then I'll discuss the collaborations that we have with some of our colleagues and some of the future plans. In terms of genome curation, manual annotation, we actually see it as a necessary step. And so manual annotation actually tries to identify those portions and genomic elements that best represent the biology of the genome of interest in a way that actually eliminates the majority of the errors that are inserted by the sequencing technologies of late. But also manual annotation helps us into assigning function through comparative analysis using proteins and sequences from phylogenetically related organisms and hoping that using the literature databases and experimental data will get us into a better representation of each of those genomic elements. But it doesn't always scale. We've had many models throughout the years. We remember the models that, like the Gene Ontology Consortium does, where a very small number of very highly trained experts are in charge of the curation and the editing. And then we've gone through models in which we find very good bioinformaticians and very good biologists in small numbers that get together for long periods of time with very little sleep to curate a lot of genes. And that only happens when you have the money that the Drosophila Project Genome had. Or the cottage where I sit in my office, curate some genes and never publish it, and then nobody knows of the great things that I did. So it's not always scalable. There's hundreds of those that could have happened. It's too many sequences and just not enough hands for curation. And that's why we thought from the beginning to set up a tool that would allow this scalability of genome curation. And so Apollo, I wish I could go through the nostalgic story of what Apollo used to be, but I don't have enough time for that. It's a fantastic project that has been going on for the last 13 years. And in its latest iteration is a web-based form, and it is integrated as a plugin to JBrowse, a very popular genome browser. It supports real-time collaboration, so every editing that happens is actually being broadcasted to all of the other clients listening. And it allows curators to have ready-made computable data that they can use. It allows to conduct annotations on different kinds of elements from the genome, including genes, coding genes and pseudogenes, as well as many other elements like non-coding RNAs. And it's all done through gestures, intuitive gestures on a slick UI, as we would like to think it is. What I'm here to talk about today mostly is the latest improvements. I will not tell you much about how to conduct manual annotations using Apollo, but rather how we're facilitating the conducting manual annotations for researchers. And Apollo's architecture, it basically has three main components. It has a web-based client in the front, an annotation editing engine that deals with all the logic for the biological aspects that are taking place every time you conduct an edit, and a server-side data service. That's all what Apollo does. And so we've gone through a number of improvement efforts, given that our community base has been growing considerably. So the first big change occurs in the web-based client. We've actually moved on to adopt a Google Web Toolkit, and we have actually been able to improve the front end and have a much richer front end and an application that allows better behavior and easier behavior. In the front, we have JBrowse, and Dojo and jQuery are part of that JBrowse environment. They have given us some headaches that I'll tell you a little bit more at the end when I go over what we learned in our errors. But the good thing is that we now have a side annotator panel. All of this is done with Bootstrap, and it has actually increased the functionality and brought back some of the features that people were used to having in Apollo at the very beginning. So that's good. And then another new thing is that we're using WebSockets and REST to communicate with the engine, with the annotation engine server. So when you're using Apollo, you have the ability to adopt a lot of different files, and I'll tell you more at the end, not just the ones that are available, but you can upload your own. And all of this is being done at the client level. Wow. I have 5 minutes left. Okay. Then we adopted, I'm going to go super speed, y'all. So we've adopted actually a Grills JVM and framework in order to be able to facilitate the way in which we conduct the annotations. And the best thing that you can see here is that we now have the ability to load more than one organism at a time, which allows improvements for comparative genomics. We weren't able to do that before, and this is quite the great improvement. And the third one is, thank you, PC. The third one is we now have a single data store that it's actually queryable. We used to have a Berkeley DB. If you've had nightmares about that before, we did too, and it was not very easy to extract data from there. So now having a single data store is allowing us to store annotations and security preferences, organisms, and tracks all in the same place, and it's all queryable. And this is what our architecture looks like now. And we're glad that we've actually been able to do something like that. And I'll tell you our horror stories towards the end, in the last minute and a half, I guess, so that I can tell you what we've learned, and hopefully you can take something productive out of the talk. This is what Apollo looks like, and this is what you were used to if you have ever used Web Apollo. This is the new annotator panel, and all of the tools that you're accustomed, such as the user-created annotations track, being able to upload your files, query the genome using BLAT, and all of those are still there. This is the panel that has all of the new things. We now have the ability to look in detail at the annotations, look in detail at each of the tracks, the reference sequence, as well as conduct certain administrative functions from the window, which was not available before. And of importance to us is that we now have recovered the ability to look in detail at all of the annotations. And so we have this panel that allows us to look into the annotation details, the intranexon boundaries, and also allows us to conduct exported all in a click instead of the more complicated way to go on the back end and extracting out of that information. There should be a video here. In the interest of time, I'm skipping it. It's 2 minutes long, but then I have some more information that I think will be more important. So if there's time, I'll come back to the video. So basically, these changes in the architecture have actually allowed us to have an easier deployment. We've actually improved and started using a Maven build framework in order to build system in order to be able to have easier deployment instead of bringing the three very disjointed components that Apollo used to have. It makes people very happy. We support multiple organisms. We have a more flexible interface, and it actually allows a larger set of sequence annotations based on the sequence ontology. So we have more elements that we're able to annotate now. In the new architecture also offers a fine-grained user group level permissions. So here's what went wrong, so that you hear the horror stories and hopefully you can get something interesting. Of course, there are unforeseen technical issues that were expected, but put some hiccups on down the road. And refactors are notoriously difficult. We actually conducted 3 in the last few months, and that was quite an overtaking. We moved to the Maven build system, as I said, the Grails in the back end, which for the Java virtual machine, and added GWT in the front end. And so it was difficult for some of the new developers because not all of us were familiar with the scope of the product when we started. So that was something that took time. Dojo gave us some interesting headaches, basically because it's very difficult to use it from the iframe to make all of the genome browsing functions available. And so what we did is we had to register a hash map of functions and push them all through GWT in order to be able to expose them. That took some going around, but we managed. And also, instead of working with the difficulties of the transactional database that we had before, we now have a relational database, and that making a lot of people very happy. So our lessons are do some research on the technologies, but then pick one and go with it instead of staying, analysis paralysis, don't wait forever. And well-written code that is mostly correct is actually going to allow you to facilitate the rewrite a lot quicker than if you just take too much time doing this. And it's typically easier to write code that meets your needs instead of hacking with what you have. So let's just rewrite. And last, I would like to say that it's better to get the data right first and then optimize for that performance instead of going for premature optimization. What we think we did right, and hopefully is something that you will be able to utilize, is we actually talked a lot with the stakeholders. So if you don't have one, find one, and find people who actually are interested in what you do and that will help you guide through that work. We did manage to choose several very robust frameworks that have improved the performance, and people are actually adopting some of those and making them their own, changing the databases and everything. And we tasted a lot of high-risk pieces before we actually embrace the technology. So it's good to implement everything in a modular fashion and take your time to do it slowly. And we involve the community as much as possible and try to adopt industry best practices and technologies. We have collaborations going on with the people from Washington State University, and I wish I could tell you all about the amazing pilot project that is taking place with the initiative to sequence 5,000 arthropod genomes. We have 40 genomes that are currently undergoing manual annotation, and we have an incredible amount of data that is coming out from that. The biology is very interesting, and it's very exciting to see how people are really putting Apollo to the test. Many future plans. The most important for you to know is that we were supposed to have released by the time I got here, but we're done with our release candidates number 2 now, and hopefully we'll be releasing within the next week or so. I hope I didn't take too much of the extra time, and thank you very much for your attention.